important, work. I take you to the world of searching new biomolecules, and the methodology has changed. You know, the chemical drugs and all these things, they are causing adverse effect in the long run. We are looking for biomolecules from the natural resources, and even natural resources are scarce, you know. We cannot, cut the branch on which we are sitting on a tree. So we have to be self-regenerative. It has to be a program which doesn't affect our environment and all that. And in that direction, I'll show you one of the areas in the modern biomolecule search. This is one of the areas I am working. Being in a senior position, I am working in a number of areas, but this is the molecular biological part which I will introduce to you. Okay. Now, this part is that, as you know, there are important anti-cancer drugs and other drugs which are derived from trees, like Taxol from Taxus baccata and computacin from Nathoprotides, and a number of other molecules. So what is our strategy? We grow the tree, we fell the tree, we extract the molecule, and then we go for the treatment. The molecule is very important. It is for fighting cancer, it is fighting some other diseases. But what is happening? Deforestation, carbon credits, as you know, global warming. This is all the effect of getting a biomolecule from the natural resources. So scientists have been working, and a new concept has come up that is looking for microorganisms which are living inside these plants. And it has been found that there is a plant microbe interaction, and as a result, many of the microorganisms which are in millions in these trees, which have either acquired the gene for the metabolic pathway of producing that biomolecule, or it has been jointly intervention of biomolecules together, and they produce that biomolecule. The biochemical pathways are shared. So either of the two. Now the concept came with the Strobalis work of getting a fungus from Taxus baccata, and he named it as a Taxomyces, and it did produce Taxol in vitro outside the plant, and it is a fungus. So the idea is that you grow the fungus, you grow it by fermentation, you isolate, keep on isolating the Taxol, and don't fell the tree. That is the concept, and that concept is called as endophytes living inside the medicinal plants. So that is the background. I'm telling. I'll not share a lot of my data because I'll not bore you with this concept after listening to other types of cards, but I will definitely share with you some of the data which we have. How to change it? Of the endophytes, yes, like that. Oh. Okay. So what are endophytes doing? The plant is giving them protection. Okay. Then they are getting the nutrients from the plants, and what plant gains? There are a lot of metabolic pathways inside the microorganisms, and for that the plant is getting all these good points: growth promotion, increased tolerance, and then induced resistance to pests and diseases. Many of these you might be finding that there are many plants. This one. BCA, biological control, biologically controlled agents. This is biological, mycotoxins and other all these things being produced. Fungi, they get a lot of resistance, pathogenic resistance in the plants, and when these fungi are grown separately. For example, if you see this slide, so these have been grown and the individual colonies are there which can be further grown like that. These are some of the known success stories which have been isolated from various plants, and these have been endophytes and commercially exploited. Okay. The benefits are the sources of the bioactive molecules, antibiotics, alkaloids, antioxidants, immunosuppressing compounds, antiviral compounds, and insecticides and pesticides. Lot of industrial application with respect to these endophytes. And again, keep on reminding you, I have not to fell the tree. That is the password. I'll just remind you that one of the very important concepts which India is also fighting these days is that funding from the World Bank for very high-end developmental programs. You go to World Bank and you ask for funds, and the first thing they ask you, what are you going to reduce the carbon dioxide content in the atmosphere because of the global warming effect. And if you say that I am cutting the trees and taking the biomolecules, they will not only throw your project out, but I think they will throw you yourself also out of the window and tell you don't come here for funding, because deforestation is not allowed. And this endophytic concept is actually that. So if you just go there, that I want, for example, Himachal Pradesh has got huge money from World Bank only for afforestation. And what is that afforestation? The specially selected medicinal plants, and they'll be used for afforestation wherever deforestation has taken place, and plant tissue culture and other so many things are being adopted to do that. So the people who are working on all Ayurveda molecules and all these herbal medicines, they are facing a huge problem because they have not to fell the tree. So that is the concept behind all this thing. So these are some of the very important examples. Taxol, I said, then other things. The endophytes have proven to be the rich source of natural molecules. The use of endophytes as biocatalysts in the biotransformation process and natural products assumes greater importance. Those who work with the biotransformation and fermentation facility, they know that if the concept yesterday came, while madam was giving the reference to thalidomide came. And I elaborated a little bit, but I can elaborate teratogenic effect. And it is an inflammatory, it's proven drug. So why it happened? Because this molecule exists in two isomer forms. One is R and other is S. One of them is actually anti-inflammatory, but the other is teratogenic. And it is very, very difficult chemically to separate these two isomers. Chemically, it's not possible at all. It is possible only with the use of enantiospecific enzymes, and this is being done by biotransformation. That is the word I want to emphasize here. That is the biotransformation. That you use a microorganism as such, or you isolate the enzyme, and this enzyme is enantiospecific. That means it hydrolyzes one of the isomer, enantiomer. And this enantiomer, if by chance is the one that was teratogenic, so you are enriching the drug with respect to the inflammatory point of view and reducing the chances of teratogenicity. So if it is 50-50, people have achieved by this thing up to 95-5. So 95 is the inflammatory and 5 is teratogenic. But this is not possible by chemical means. So that is the importance of, you can again put it back. Large biomass can be produced, and production of amplification stability, availability of the less sophisticated and time-consuming method for genetic manipulation. You can further upscale and further improve the the molecule there by other means. This is just to show you how it is done. So how it is done is like that, that you take the sliced bark or something of the medicinal plant, and then you allow it to grow under absolutely aseptic condition. It should not be as an endophyte, which was actually a contamination. So it will grow like this, and this is done under absolutely no growth conditions, water agar. So there is nothing, you are not providing any. If you are providing, then anything can grow. So this will grow like this, and then you have to purify the colonies and things like that. So that's how things have been are doing, and we are isolating it. So how the methodology is that the collection of the sample, isolation, and on one side DNA isolations and characterization to know the phylogenetic position of the fungus, and the other hand that you look for enzymatic and antimicrobial work, the biomolecule. So, we in fact are looking for amylases, cellulases, lipases, laccases, and proteinases, some of the industry demanded molecules, which should be better than what is available in the market. And since these microorganisms are not easily accessible, they have been isolated from inside the plant, so they might contain something better and good molecules. But this is just sequencing and then finding out the results. In fact, students included all these data. These are some of the things which we have. No, we have concentrated on Withania somnifera, ashwagandha, everybody, very important. Then Muraya, and these are the plants which we are concentrated on. And these are the fungi which we isolated, and this percentage shows the sequencing after NCBI sequencing, and then coming out of it. Some of the patents which we took earlier doing this work. This was particularly for the competitive. This is also an anti-cancer drug from Nathopodiatis, and podophyllin. The podophyllum is also a very important plant for podophyllin. So these are the two patents we have taken for these other things. In fact, there are 5 patents and 2 have been granted. This is the area we are concentrating on, J&K, and these are the areas where most of the plants are being isolated. Some of the pictures of the fungi, these are the chemical data, who are some chemists sitting here around for their if you declare that my fungus is growing, is having computocin, you have to prove it. And you have not only proved by HPLC, but you have to prove it by GM, MS, mass spectrophotometry and all that. So this is all that data to prove that, well, of course it is computocin and not anything else. Other NMR data and IR data and things like that to prove that this is. So these are some of the plants we took, and these are some of other information which we had. Just to show you which are these. I think it's got a little repeated here. It's showing the enzyme activity. Such slides you have already seen. The first isolations are actually being done by this method. So see, if you are looking for an activity, it is something like that. All are not producing, only these are showing the activity. These are showing the activity. So such things are actually isolated and purified, grown by mass production, that is by fermentation, and then identified. Some of the data of, against standard pathogens. Normal method, how your sequencing has to be done, and some of the other data, . This is the group working with me in the lab, particularly on this aspect. Thank you.